Hey everyone, we are going to go over your Chapter 4 review in this video. All right, so go ahead and take a minute and start checking the answers that you have. If you need to pause at any time to check your answers, feel free, and then I will go through and explain every question as well. All right, so if we look at number one thing that I want to make sure you guys understand is when we tell you to classify, we're talking right, obtuse, acute, equiangular, isosceles, equilateral, scalene. You've got to know classify does not mean, some people have put like side angle side for strange things. Classify is telling me if we're by angles, it's these three plus acute. And if it's side lengths, these are the three side length classifications. So sometimes people struggle with what it means to classify. So please make sure that you understand that this is what we're looking for, again, plus acute, in terms of classifying your triangles. All right, so we're going to first look at triangle ACD, which is this triangle right here. Okay, I can see that in this triangle, this top angle is 30 degrees. This angle right here is 60 degrees. I know that this one is 90 because this one over here is 90 and they make a straight line. All right. So because this is a 90-degree angle, I know I have a right triangle. All right. The next one that we're going to look at is triangle ABD, which is everything we just did plus this one. So this whole blue triangle is triangle ABD. Notice that this is 60, this is 60, and this whole top angle up here is also 60. Now, those are all acute angles, but they are also all equal. So equiangular is the best answer. All right? If one of these was 61, the other 59, then we would say acute. But if all three are 60, then that means they're all equal. We have an equiangular triangle. All right, the last triangle we're going to look at is triangle ADE, which is this triangle right here. All right, so what we look at here is I know that if this angle is 60, these two angles right here are going to make a straight line, which means they are a linear pair and they add to 180. So if these add to 180, I know that this angle right here is going to be 120 degrees because 180 minus 60 is 120. I don't need to know what these two angle measures are. I know that 120 degrees is obtuse, so I have an obtuse triangle. All right. 4 through 6. Notice that all four of these sides are marked the same. So I went ahead and labeled each of them with 5. I know that this whole side length is 10. So if I want to classify my triangle by its side lengths, if we start with PQR, so right here, it's this triangle. All right. I see that these two sides are both 5 and this side is 8.7. So I have two congruent sides, so my triangle is isosceles. All right, when I look at the next one, I'm looking at triangle PRS, which is this triangle right here. All right, all three sides are the same length, so it is equilateral. And the last one is triangle PQS, which is the whole big triangle. So we're looking at the whole thing. Okay, this side is 8.7, this side is 5, this whole side is 10. So for triangle PQS, all three sides are different lengths, so the triangle is scalene. All right, let's take a look at the next set. All right, for this set, we are using the exterior angle theorem. People have been struggling with this theorem for a little bit during this chapter, so we're going to make sure we talk about this pretty well. All right, this theorem is in section 4.3. All right, and it is example 3. So there's a theorem right above example 3, and example 3 goes through the exterior angle theorem. All right, the exterior angle theorem says that our exterior angle, which is this one right here on the outside, is going to be equal to the sum of the two remote interiors, which are these two angles. So this angle here is going to equal the sum of these two angles. So it's the two that don't touch it. All right. So that's what we're setting up here. This 151 minus 2y is equal to the 6y plus 3 plus the 84. So when we're looking here, this is the equation that we set up when we have that exterior angle. All right. We set those equal to each other here. We solve, we get that 8 is y. Now, notice I'm asking you for the measure of angle M, which is right here. So I'm going to take 8 and I'm going to plug it in for y to actually get the value of that angle. All right. Same thing over here for number 8. My exterior angle, which is right here, it's the one that is outside the triangle, is going to be equal to the sum of the two remote interiors. It's those two inside ones that don't touch it. All right, so my 20x minus 15 is going to be equal to 5x plus 90. All right, so it's going to be these two together, which is what I've got set up right here. We solve, excuse me. So we're going to solve for x and get that x is 7. All right, again, I wanted the measure of angle ABC here. So we are going to plug 7 in for x with angle ABC. That is the exterior angle. And I'm going to get that angle is 125 degrees. All right, 9 through 12, we are given a congruence statement. So this is all we need. If I know these two triangles are congruent, I can match the pieces and parts that go together. So KL is the second and third letters. So EF is going to be the second and third letters. Now, if you have FE, I will accept it because it is the same segment. But in general, we want to match letter for letter. All right. The next one is DF, which is the first and the third letter. So we need the first and the third letter in the other triangle. So that would be J and L. All right, for number 11, E is the middle letter, and so is K. So these are the ones that go together. So we're given K, we know E. And the same thing is true with 12. F is the last one, L is the last one. So these are the ones that match up. All right, let's take a look at the next set. Again, don't forget you can pause at any time to check your answers more fully before starting to go over them. All right. I cannot stress again how important it is that you are marking on your pictures. Marking on your pictures is going to be what helps you determine why your triangles are congruent. So we were given these were congruent. We were given these were congruent. I'm going to mark that reflexive step every single time. All right, I have 3 pairs of sides congruent, so that's side, side, side. Again, you want to look at just one triangle when you are looking to see why your triangles might be congruent. All right, so I've got all 3 pairs of sides here, so it's side, side, side. When we look at 14, I should always see those vertical angles, so I can mark those. Now, I know that these sides are congruent, but that's it. The only things that we can do to mark sides are congruent is if we're told we have a bisector, we have a midpoint, or they're reflexive. Okay? If it's not given to us, we've only got 3 ways to show sides are congruent: reflexive, midpoint, or bisector. We don't have any of that information here. So we only know 2 things. We know 1 pair of sides and 1 pair of angles. All of our shortcuts use 3 things even HL, because remember we need a right triangle. So we need 3 things to show triangles are congruent, so this is not enough. Over here in number 15, I'm given that these 2 sides are congruent and these 2 angles right here are congruent. Again, I can mark that reflexive step. Then I'm going to look just at one triangle and see if I have enough information. And I see that I have a side, an angle, and then a side. The angle is between the 2 sides, so I know my triangles are congruent by side, angle, side. Number 16, I can mark that reflexive side. But again, I cannot mark the 3rd pair of sides because I don't know that those are congruent. That's not given to me. I don't have anything that says midpoint or bisect, so I cannot mark those sides. I also don't have any information about any of the angles. If I was told that these were parallel, then I could mark these. But I'm not given parallel, so I don't know anything other than what is already marked here. That's not enough information. It's only 2 things. All right, number 17. All 4 of these sides are marked congruent, and I can mark my vertical angles congruent. So again, if I'm looking at just one triangle, I have a side, an angle, and a side. The angle is between the 2 sides. I have that angle where the 2 sides meet, so it is side, angle, side. All right, number 18. Now, I'm given that these are parallel, which means I can mark this pair of alternate interior angles. So basically what I know is true here is I've got this. All right? I don't know anything about these sides, so I cannot mark anything over here. I know like this whole angle and this whole angle are supplementary, but that does not actually help me with anything. All right? So those are the only angles that I can mark when I have just one pair of sides parallel. All right? I can also mark that reflexive step. But I don't know that these 2 sides are congruent. I only know that they're parallel. So again, in one triangle, okay, again, look at one triangle at a time. I only know one angle and one side. I don't know anything else is true within this triangle, so these are none with not enough information. All right, number 19, we don't need to mark anything else. I've got an angle, and a side. The side is not between the 2 angles, so it is angle, angle, side. Number 20. With number 20, we could mark one of 2 things, or we could say this one of 2 ways. I know that this side here is congruent to this side. That's given to us. And I know that this side is parallel to this side. Well, when I look here, I've got a pair of alternate interior angles here and here. All right, that's angles A and E. So I can mark those congruent. I also, if I look at the other transversal, I have a pair of alternate interior angles here, and that's B and D. So if I mark both pairs of alternate interiors, I have an angle, and a side. So I could do angle, angle, side. However, if I mark the vertical angles as well, I could have said angle, angle, side this way if I marked this pair of alternate interiors. Or I could say angle, side, angle this way if I marked this pair of alternate interiors. So there is a good case for either of these. It just depends on which ones that you saw, which ones you marked. So again, if you marked it this way, that didn't go very well, here, 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 and here, okay, you would have had angle, angle, side. All right, if you marked it this way, you would have still had, whoop, that would have been down here, not here. You would have still had angle, angle, side. Okay? And then if you marked it this way, you would have had angle, side, angle. All right, so either of these can be correct depending on exactly how you marked it. All right. Number 21. I see that AC and BD are congruent. I see that angle DCB and CBA are both right. And then I can mark that reflexive step. So when I look at this, this is an angle, a side, and a side. The angle is not between the two sides, so it is not side, angle, side. All right, this is the one that does not work, angle, side, side. However, that angle is right. So remember, when we have an angle, side, side with a right angle, we need to look for HL. So I have two right triangles, my hypotenuses are congruent, and I have a pair of legs congruent. So that is why HL is the case here. All right. Let's look at the proof. All right, we've got our given statements right here. We know where we're trying to go. So again, I don't want you to look at anything over here until you have marked your picture. All right, we are given that RT bisects angle QRS. So if this angle here is bisected, that means it is cut in half. So if that is bisected, I know that these two angles are congruent. We should have marked this. All right, we're given angles Q and S are congruent, so we need to make sure that those are marked. I can also mark that reflexive step. So now, mark your pictures first. Then we're going to look over here and make sure all of these things that we have marked are in our proof. All right, angles Q and S is in our proof because that's given to us. All right, again, this was also given to us. But I also marked angle QRT and angle SRT. I marked these two angles right here. So I need to make sure that those marks are in my proof. So now what told me this was true? The word bisect told me that these two angles were congruent. So it's my definition of a bisector. Then I have RT is congruent to itself. That's our reflexive step. Okay. Now I have enough information, angle, angle, side, to show that my triangles are congruent. So that's what's going to go right here. Now remember, once I have congruent triangles, I know all the other pieces and parts are congruent by CPCTC, which again, remember, is corresponding parts of congruent triangles are congruent. All right. So please make sure that, again, you're looking at these when you're doing these proofs, you are looking at the picture first. Mark the picture first, and then put those marks in the proof. It is so much easier if you do it that way than if you try to do it by just looking at what's in the proof. All right, start with the proof, start with the picture, then go to the proof. All right, 22, what's the distance formula? Check your formula. Make sure your subscripts are truly subscripts. Your superscripts are superscripts. Okay, this does not work for me. Okay, or this should not be up here. You need to make sure that it is a subscript. All right, then what would we use the distance formula for in a coordinate proof? Okay, we use anything that shows side lengths. Okay, so we can show triangles are congruent by side, side, side. We can also prove that a triangle is scalene, isosceles, or equilateral. Okay, so we can classify triangles by sides as well. All right. Slope formula. Make sure again that you're checking your formula. y2 minus y1 over x2 minus x1. Okay, and I use my slope formula for telling whether two sides of a triangle are perpendicular, which would prove that the triangle is a right triangle. All right, midpoint formula, making sure that we have this again correctly. Then we use a midpoint formula to determine whether or not a segment is bisected, okay, or if you need the coordinates of a midpoint to use it for something else. So almost all the things that we did in our examples, we said, hey, I want to show like that midpoint triangle was still isosceles. Well, we needed the coordinates of the midpoint to use it for something else. So that's another thing that you'll see a lot in coordinate proofs, is not necessarily just using the midpoint formula, but using the midpoint formula to get those coordinates to then use distance formula or to use slope from there. All right, and our last sets, again, we're going to prove that our triangles, or classify our triangles by both sides and angles. All right, again, this is another one that we tend to struggle with, and I want you to look at the key concept and example 4 in your 4-2 notes. So this is when we're taking c squared and we're comparing it to a squared plus b squared. All right, again, remember that c squared is the longest side. All right, and a squared plus b squared can be either one. All right, the other two sides are over here, but that c needs to be the longest side. All right, so with this one for number 25, if we were to sketch where this is on a graph, I've got 0, 0, 4, 0, and 0, 2. All right, so I know that this side length is 4. I know this side length is 2. What I don't know is this side length. So that's where this comes in right here. All right, we're going to do distance formula between these 2 points in order to know how long this side is. And that's what's going to give me that square root of 20. All right. Now, we need to know which side is the longest side. So I put square root of 20 in my calculator, and I get that it's about 4.4. So it's longer than 4 or 2. That means the square root of 20 is my c. So I'm going to compare the square root of 20 squared with 4 squared and 2 squared. These are my a and my b. They're the smaller 2 sides. Remember, anytime we square a square root, it's just the number, which is why we did not take this and reduce it to 2 root 5. All right, we don't need to do that, because then when I turn around and square that, I would have to remember to square both the 2 and the square root of 5. So that gives me 4 times 5, which is 20. So it's easier to square the square root of 20 than it is to square the 2 times the square root of 5. Either way it works, but more often than not, this gets messed up. But please make sure that you do know how to do this in case that's what's given to you. All right? So when we do the square root of 20 squared, I get 20. 4 squared is 16. 2 squared is 4. So 20 is equal to 20, which means I have a right triangle. Now, all 3 sides are different lengths, so that means the triangle is also scaling. Okay? Over here, I've got side lengths of square root of 10, square root of 10, and 5. So if I put the square root of 10 in the calculator, it is 3.1. So I know that these two are smaller than 5, so 5 is my longest side, so it is my c. All right, so I do 5 squared is 25. Square root of 10 squared is 10. So 10 and 10 add to 20. So 25 is greater than 20, which means that it is obtuse. So my c squared is greater than my a squared plus b squared. So that's why it's obtuse. If it was less than, then I would have a q. Now, when I look at my side lengths, I have 2 sides that are the square root of 10. So my triangle is isosceles. All right, so this one we were given the side lengths and we want to classify by sides and angles. This one I'm going to be given the angle measures and be classifying by sides and angles. All right, So when I look here, I have 50, 50, and 80. All of these numbers are smaller than 90, so I know my triangle's acute. Both of these are 50. Remember, in an isosceles triangle, those base angles are going to be congruent. So anytime I have two congruent angles, I know my triangle is also isosceles. If all three angles were different, then it would be scalene. All right, when I look here, all three angles are the same. So that means it's equiangular. And any triangle that is equiangular is also equilateral. All right, so again, we don't want to say acute here because when we look at an acute angle, it's not the most specific name. Okay, yes, all of these are acute, but it is more specifically equiangular, which we kind of talked about a little bit earlier. All right, so again, equiangular triangles are also equilateral. All right, if you have any questions, you need to make sure that you are asking them in class. So please make sure you are asking me any questions that you have, and I will make sure that those get answered for you so that you are prepared for your test. All right, have a great day, and we'll see y'all later.